So hi, it's that time again, mailbag. And I've got a few here, but there's a few different things, I think. A few things I'm not sure about. And actually one or two have been sitting on the side for a couple of weeks. So let's make a start. Can't necessarily remember what everything is, really. Yeah, oh yeah, okay, I know what these are. So this first one is a set of fairly short, it turns out. So I reckon they're only 600mm, those 2 foot. And they are Kelvin clips. They're not very expensive ones, it has to be admitted. These ones are going to BNC connectors, which are pretty cheap and nasty. But they're only for a few jobs that I need from time to time, and I do think, despite the fact that these aren't particularly engineering wonders, they're going to be better than not using Kelvin connectors for the odd test. Anyway, I mean, spring loaded, they feel all right. I think they meet at the ends, so yeah, they're all right. They'll do the job. I'll just hang them on the door like I normally do. Okay, what's in this one then? Oh yeah, this looks like it would be from, yeah, I recognise the box colour straight away. So thank you very much JLC PCB for making small PCBs. They do not sponsor this channel, just to be clear on that. I don't have enough subscribers at the moment for them to do that. There should just be 5 little PCBs in here, hopefully. So these are just some real simple PCBs. Let's see if I can zoom in. And yes, I think it says on here, it's an RF splitter. So this is a resistive RF splitter, and this is done on an impedance controlled board. And you can see obviously there's lots of stitching for the grounds and things like that. And yeah, so that should be okay. There is actually, as well as the ground plane that's on the back there, there is actually an internal ground plane to achieve the impedance match on the surface. Now, because I didn't have the right size resistors, I can't remember what they are, 37.6 ohms, something like that I need to do this perfectly. I've had to use 2 resistors in series. Now, I don't mind that actually, because that gives me a bit more headroom in terms of power dissipation within this. So there's a total of 6 dB loss on one of these. You automatically get 3 dB loss because your signal is split into 2, so there's minus 3 dB straight away on both sides, but you also get a 3 dB attenuation within this resistor network as well. But I just needed some low frequency ones that would go down to up to about 1 gigahertz and down to DC. So I decided, rather than buying them at an incredible price, I would just pop a few together, and I will pop them into a box. Make those up on a future little project build. Okay, so this is a very small module. So it's got a tear point on it, but I'm going to just cut it as usual. And yeah, this is one of those small PIR modules. So you see a PIR lands on this end, going off the board. And then a bit of circuitry just to decode that, so you just get a digital output on this end, and they're only like, yeah, £2 or £3 a pop. Certainly beats messing around doing all that circuitry yourself. And there's 10 of something in here. A668 times 10. Oh yeah, okay, cool. So these, again, let me switch camera here, are SMA connectors for that little circuit board that I was showing you earlier. So there we go. So these are the ones designed to fit through a panel and be screwed to the panel. And I've done this board so that I can either put one in that way and then two in that way, or these can actually go out the sides instead. And of course you don't have to use these, you can use normal ones that don't have this ridiculously long thread on them as well. But it's quite nice to have that thread, just helps tidy everything up in terms of making a good panel connection. Okay, the one from Amazon as always. There's always something from Amazon. I like to try and use other things, but... oh yeah, right, okay. Yeah. Very important for all electronics engineers. Indigestion tablets. Okay, I hadn't really kind of, well, anyway. No doubt I'll leave that in. Okay, here we've got something else. Now this is from a local charity, and they buy in some return stock. So they buy like a pallet of return stock, and they'll then sell some of that on. And on there was this particular device, which isn't really in their ballpark to know what to do with. So they passed it on to me. Now what I'm going to do with this is I will test it out, and if it's okay, then I will flog it on behalf of the charity and send them the money. So here we go. So my initial thought was that this was a Wi-Fi controlled relay board, but it turns out to be a Bluetooth board instead. So this is a off-the-shelf Bluetooth module just here with a microcontroller on it. I doubt we can get close enough to see. I will do my best for you. So I can't quite make that out entirely, but you know, maybe some of you can on the camera. So Bluetooth module here, and we can see that it's got a couple of tracks going out onto this IC here. We've got some inputs here going through opto isolators, which will also, since this side here is going to be 5 volts essentially, or 3.3 volts, whatever it is, and that's going to go into this IC here. And this will be a bit of logic. It's probably just a bunch of AND gates or something like that. It might be NANDs or something, who knows. But so a bunch of logic coming in here and then going out to this guy. This is a transistor array to drive the 4 relays, and these are 5 volt relays, and they'll drive 250 volt 10 amps. So pretty decent really overall. The only thing, and I would have just given the charity some money for this, but yeah, I don't really have a use for it, unfortunately. If this was a Wi-Fi board, then I definitely would have some use for it. But as it stands, yeah, it's a Bluetooth, and yeah, I'm never going to use it. It'll be in my junk bin forever. So yeah, I will test this and flog it now. I have managed to find the phone app for this without any real problem, and I'll do a little video where I test this out and drive it from the phone app, and we might have a look at the API as well and just see how easy it is to write your own piece of logic. But yeah, interesting little bit of kit really. It's got a couple of voltage regulators on there. It's got a jack which says 5 volts, but it says DC 5 to 24 volts. So I think that this input jack here could be various voltages. Then we've got a V in here, which I suspect is supposed to be on the block, which I suppose is supposed to be probably the right voltage, but I'll trace that out when I come to actually do a little review on it. Now, I do know what this is. So, okay, so quick look at this. So this is the solar iBoost. Gives you free hot water from your PV array, and straight away that isn't true. It's not free hot water unless you're on the old UK feed-in tariff, in which case it is free. But for most of us with solar arrays nowadays, then we get paid per kilowatt that we export. If we don't export it and we use it to heat our hot water instead, then actually we don't get as much money in, so we lose money from. We gain money from one side because I don't need gas to heat my hot water, but I lose money from the other because I don't get export payments. So it's not free. There is a cost attached to it. On the old feed-in tariff, since the amount that you actually export doesn't alter your payment at all, then yeah, you're probably okay to say that's free. But for most users, that isn't the case nowadays. And there's a lot of amounts of saving that you might make quoted in a lot of the adverts, most of which are completely unrealistic. So here's a simple fact. You can't save more heating your water than you pay to heat your water. Now, I've looked at how much gas in fact I use to heat my water. I can actually see that very easily on my bill because the hot water is heated at a specific time of day every day, and we don't have any other use of gas at that time. So I can actually isolate the heating of water, calculate its cost exactly over a long period, and see exactly how much I'm spending. So what I'm going to cover in the video is popping this in, generally speaking what it does, which is that it diverts excess electricity. So instead of exporting it to the grid and getting paid for it, you use it to heat your own hot water. Now I'll talk about the cost benefits of that and for who it is and isn't worth it. Now, as it happens, my electricity deal hasn't yet run out, so I'm still paying the same price I paid last year, despite the fact that electricity and gas costs have gone through the roof. Why did I buy this now then, instead of waiting till my electricity and gas prices actually go up? The answer is very simple. I think there's going to be a lot of these sold and the price will go up. In the UK, we've got inflation pushing up towards the 10%. We've got difficulty getting components to make things like this. There's only one way the price is going to go, and as people start seeking ways to mitigate their increased gas costs and things like that, then sales of these have got to increase, and with increased demand equals increased cost. Or, in my words, profiteering. Anyway, now seems to be an optimal time to buy it, despite the fact that I won't actually benefit for nearly a year. But let's take a quick look inside. So we've got the obligatory manuals, super duper, some instructions on installation. And seriously, if you don't know how to install one of these without the instructions on how to install it, then they should just be fine detail for you. If you don't know how to do that, if you don't get it, don't install it yourself, just get an installer, don't mess around. So one of the reasons for choosing this, there are a couple of others that I was thinking of, is all of them have these current clamps that go around your cable near your meter or near your consumer unit or whatever. And they have to feed back to the actual device, which is going to be in your airing cupboard next to your hot water cylinder and your immersion heater. And of course, if you haven't already got those, then you have to include those in the price of your installation. And is it sensible, if you haven't got a hot water cylinder, to even have one, because you must have heating on demand, which is probably more efficient than one of these. Anyway, here we go. This clamp goes onto the cable to measure how much electricity you're importing or exporting from the grid. Then this one has this. So this is a wireless transmitter, and literally this guy plugs in it and the batteries go in, thank you very much, and it transmits the current level of imports and exports up to this device here. One side of this goes to the immersion heater, the other side goes up to your dual pole isolator and fuse spur that you've got for your immersion heater, and basically it will be replacing your timer switch that you already have for that, and that's about it really. So this then will, whenever you are exporting electricity, it will try and grab that electricity and use that amount of electricity for your immersion heater. One of the reasons it's very big is that it contains a fan. It contains a fan because this is proportional control. So it doesn't just turn your immersion on and off. If you've only got, let's say, 800 watts of export, it will only provide 800 watts to your immersion heater, despite the fact that your immersion heater would like to run at 2.7 kilowatts or whatever. This will limit the amount of heating to only use your excess electricity, and that's its purpose. So I think that's probably enough on it. We'll go over that all again in the video, and of course look at the cost benefits and think about things like, how does this work with a solar system that contains batteries, for example. Anyway, that's enough of that. I'm going to go and deal with my indigestion, and I'll see you next time. Take care. Bye for now.